Design case study for solar home systems for the DC load. In this session, we're going to be talk about when the consumer is consuming in terms of the DC loads actually. So that time how we can design the solar home system. So what amount of the solar panels, the battery and the solar charge controller be required, and how we just size this corresponding parameter as per the site information and the load calculations over here. So for that purpose, we take a problem statement over here, that is design a DC solar home system for the given DC load shown in the figure, that is shown in the following table over here, which is used by the small home systems over here. Design a DC solar home system in a such a way that it should satisfy the need of the consumer at least for the 5 hours. So for that purpose, we have to collect the information regarding how many equipments the consumer is using actually. What is the individual wattage capacity of the individual equipment, total numbers of the equipment, and then we can further do a process for sizing of a battery and the further parameters over here. So for that purpose, we require to collect the information regarding the load information. So consumer is using the DC fan, DC LED light and the DC tube light. So the individual power rating in terms of the watt, it has been given over here 27, 10 and 18. Total number of a quantity of a fan, LED light and the tube light has been mentioned over here. In the fourth column, the load parameter has been given. So whatever the individual rating of the equipment multiplied by the total numbers of the equipment. So whatever answer we are getting, so that we can put it over here. So it is a 81, 50 and 54 continuously and simultaneously over here. The last column is consisting of the duty cycle. It means what the individual DC instrument what consumer is using, how many hours that corresponding equipment is having in the working condition over here actually, or how many hours the consumer is utilizing this corresponding equipment. So that part in terms of the hour we have to be mentioned over here. So it is a 666 hours the consumer is using the corresponding equipment actually. Once we know the basic load information, once we know the power rating of the individual parameter, total numbers of the quantity, the total load in terms of the watt and the duty cycle, then we can go for the watt hour consumption calculation for the consumer. So this we require to calculate the kilowatt hour consumption of the consumer in the daily basis. The electricity unit, that is a one electricity unit, has been measured in terms of the kilowatt hour over here actually. From that we can estimate how much amount of the kilowatt capacity of a solar plant or a solar home system to be required to satisfy the need of the consumer. So in this table will be similar in the earlier slide we have seen. Only the last table has been added over here, that is a consumption in terms of the watt hour. So basically in terms of the watt hour consumption, when we are considering, it is simply the load in terms of the watt multiplied by how many hours the corresponding equipment is working over here. So 81 multiplied by 6, we are getting the answer of the 486 over here. Similarly, the 50 multiplied by the 6, we are getting the answer as an 300. 54 multiplied by 6, we are getting the answer as an 324 over here. So simultaneously we have just calculated what is a watt hour consumption for the individual equipment, and the total watt hour consumption on the daily basis for the consumer, it is a 1110 watt hour over here actually. So once we know on the daily basis how much amount of the watt hour the consumer consuming in the daily basis over here, then we convert this watt hour in terms of the kilowatt hour. So we have a 1110 watt hour over here. Divide this value by the 1000, you are getting the answer in terms of the kilowatt hour over here, which is a 1.11 kilowatt hour. So this much amount of the unit the consumer is consuming actually on the daily basis after consumption with the help of such kind of a load in terms of the DC actually. Once we know in the daily unit basis how much amount of the consumption the consumer is having, then we can estimate the solar power plant capacity actually. Before we just find this corresponding capacity, there is one thumb rule actually, that 1 kilowatt of the solar power plant produces 4 to 5 units daily basis on an averagely over here actually. This is the thumb rule most of the times used by the solar installers who is actually installing the solar power plant on the site. So basically there is another standard methods are also there. From that we can calculate how much amount of the exact unit will be generated by the solar power plant. But this unit, what it is generated exactly, it is changing on the daily to daily basis actually. On the summer season, winter season, rainy season, some cases the 2 unit, some cases 6 unit or to 5 unit, likewise it is being generated. But on an averagely, whenever we do the calculation, so that time we are taking that the 1 kilowatt of the solar power plant produces the 4 units of the electricity on an averagely on the yearly basis over here actually. So daily the 4 unit it has been generated that we are consuming. In some cases the higher unit might be get generated in the winter season or the summer season places over here, and in some rainy season or the snow falling season over here actually might be the lesser than the 4 unit getting generated in the situation actually. But on an averagely the thumb rule has been utilized worldwide actually whenever we do the calculations over here. So the consumer is consuming daily basis, it is a 1.11 kilowatt hour of the consumption. So we just divide this daily basis consumption divided by the 4 units. The unit electricity we can measure in terms of the kilowatt hour only. So 1.11 divided by 4, we are getting the answer of 0.278 kilowatt over here actually. So basically in this case, if we see this logic over here, basically how we just calculating the solar power plant capacity in terms of the kilowatt hour. So in that cases actually whatever the daily consumption the consumer is having divided by the 4 number of a unit we are dividing. The reason is that we just comparing that the 1 kilowatt produces the 4 units, then 1.1 unit if I want to generate from the given solar home systems, then how much amount of the kilowatt capacity will be feasible to be installed. So like that we are just comparing this over here actually. So in these cases, whenever we develop or whenever we calculate the sizing of any solar power plant, the daily basis unit divided by the 4 we are doing it over here according to the thumb rule, and we can calculate what is the solar home system will be feasible for the consumer so that it will satisfy this corresponding load requirement over here actually. Once we know how much amount of the solar power plant will be feasible, which is a 0.278 kilowatt, we just convert this value in terms of the watt by just multiplying by 1000 over here. So we are getting the answer which is a close to 300 watt. We can take it over here actually. This is actually the 278 watt, but close to the 300 watt we can take it over here for the safety precautions over here actually. So once we know that we want to install the solar home system for the capacity of the 300 watt, so that time we have to take a decision that which rating of the solar power plant we have to be considered. So let's say in this case study we're going to be consider the 100 watt peak of the solar panels, and that to be the Vari company who is manufacturing the solar panels actually. So before we do some kinds of the calculation, we must know what are the parameters or the tested parameters are there for this corresponding wattage of the solar power plant as per the data sheet of the solar panel actually. So in this case, we have a module parameter for the solar panel which we have selected as an 100 watt peak over here. So peak capacity of this panel is the 100 watt peak. The maximum power point voltage is 17.47 volt. Maximum power point current is 5.73 ampere. Open circuit voltage is 21.97 volt. Short circuit current is 6.07 ampere. Maximum series fuse rating is 12 ampere. Efficiency of a module is 14.31%. And the rated voltage of a module, whenever the manufacturer is saying that any panel has been manufactured, so the 100 watt peak is having the rated voltage as per the data sheet when it displays on the website or any kind of the data sheet, it is a 12 volt over here. But the maximum power point voltage generated by the solar panel is 17.47 volt actually. So for the calculation, we can just use this maximum power point voltage and the maximum power point current over here. So once we have selected the solar panel, the next procedure is to calculate the number of solar panels over here actually. So how we can calculate the number of solar panel? So the formula is that what is the daily load consumption the corresponding consumer will have. So basically whatever the solar power plant capacity will be, so that also we can choose it over here actually. the capacity of a solar power plant that we have to install in the consumer rooftop area, so that we convert in terms of the watt over here. So we have to install the 300 wattage capacity of the solar home systems over the consumer rooftop area. So we just take that load consumption over here actually, or simply we can take the size of the solar power plant that we want to develop over here, so that we can take either in terms of the kilowatt or in terms of the watt. But the panel rating what we are selecting, it is given in terms of the watt peak, so we have to convert the kilowatt in terms of the watt over here actually, simply multiplying by the 1000. So in this case we have 300 is the solar home system design we want to design actually, divided by the individual solar panel rating we have to select. So in this case we have selected the 100 watt peak of the Vari solar panel, so that we have to divide over here. So from this we get the answer as the 3 numbers of the solar panels are required to satisfy the capacity of the 300 watt solar home systems over here. So once we have just decided how many numbers of the panels are required, now our task is what? How we just do the connections of the solar panels, rather in the series connection, rather in the parallel connection. But before we proceed to find actually how we just connect the panels in the series or parallel combination, whenever we do the panel connection in the series combination, it means what? The negative of one we are connecting to the positive of the second. So like that, the opposite connections we are doing it over here, it is called as the series combination over here. So in the series combination, the voltage is continuously increasing and the current will remain same over here actually. In the series combination, the voltage is increasing and the current will remain same over here. But whenever we are joining the panels in the parallel combination, the voltage will remain same, but the current will going to get increase over here actually. So in that cases, whatever the positive of each panel will be there, that we are combining by the pre-assembled wire, and whatever the negative of the each panels are there, that we are combining to the negative of the wire over here. So you can see in this diagram, the 3 panels has been connected in the parallel combination. So the positive wire we just clubbing at a single wire, and negative wire we are clubbing as a single second wire over here, and combine output we can give it to the solar charge controller over here. So basically, whenever we see what is the output that we are getting after connecting the panels in the parallel combination, the voltage of each panel we know it is a 17.47 as a maximum power point voltage, and the current of the each panel will be the 5.73 ampere. As the 3 panels are connected in the parallel combination, the voltage will remain same. So whenever we test with the help of the multimeter, so we'll get the answer of the voltage as 17.47 volt. But the current will remain increase over here actually. So which is a 5.73 multiplied by the 3 solar panels. So we are getting the current of near about the 17.19 ampere over here. So whenever we measure with the help of the multimeter, so we will find the current of the 3 panels are 17.19 ampere over here actually. So like that we can do the connections over here actually. Now why we are connecting the panels in the parallel combination, that will going to explain in the further slide over here actually. So now we're going to see actually how to size the solar charge controller in the solar home system over here actually. One thing I must tell you over here, whenever we see the market standards of the solar charge controller, the controllers are available like in this format, like a 12 volt solar charge controller is available, 24 volt charge controller is available, 48 volt is there, 96 volt is there also. So like that, whenever we see the voltage of the solar charge controller actually, it is in the multiplication factor of the 12 volt over here. It is also called as the battery bank rating. Also we can just decide the solar charge controller, or in the system voltage when we are talking actually. So in that terms also manufacturer is giving the voltage rating of the solar charge controller. So basically the main role of the solar charge controller is to charge the battery actually. So either we connect the 2 battery, 3 battery or 1 battery over here actually. So the solar charge controller sends the specific amount of the voltage towards the battery and specific amount of the current towards the battery, so that the battery is getting charged over here actually. We know whenever we see the market standards of the battery, we are getting the battery in terms of the 6 volt, we are getting the battery of the 12 volt, the 24 volt also we are getting, 48 volt also we are getting actually. So basically the charge controller what we are selecting, it depends upon the multiplications of this particular 12 volt for 24 volt and the 48 volt. It is due to the charge controller is used to charge the solar battery actually, and this solar battery is having the typical amount of the voltage in the multiplication factor of the 6 or the 12 over here actually. And that is why whenever we size the solar charge controller or whenever we do the connections of the solar panels also, so that time we have to keep in mind that. So if we are selecting the 12 volt of the particular solar charge controller, so it means that this controller is having the voltage acceptability range from 1 volt up to 20 to 25 volt over here actually. But the rated standard voltage of this corresponding charge controller is the 12 volt over here. So every solar charge controller will have the maximum limit actually. So how much limit the solar charge controller will take the voltage from the solar panel. So that is depends upon the corresponding rated capacity of the charge controller. So that is why in this diagram, whenever we see this diagram actually, the three panels are connected in the series parallel combination over here. So we are just making the voltage same over here actually, because we are selecting the charge controller in the range of the 12 volt over here actually. So near about the 12 volt, so this voltage can be acceptable by the corresponding solar charge controller over here actually, because though we have selected the rated voltage of the 12 volt, but every solar charge controller will have a maximum tab up to the 20 volt or the 25 volt. The 12 volt rated capacity of charge controller can accept the voltage from the solar panels actually. The second situation is what? Whenever we are connecting the panel in the series combination, so it will become the 17.47 multiplied by the 3. So we are getting the voltage more than the 50 volt over here actually. So this is not being connect, we can not able to connect this corresponding connections towards the solar controller over here actually. So there is a second method. If we are connecting the panels in the series combination, then what solar charge controller is required? It should be the NPPT charge controller we have to use. In the solar NPPT charge controller, we can accept the maximum amount of the voltage from the solar panel, and we can give the rated voltage for charging of a battery. If we are going for the cost cutting application, and if we are selecting the PWM pulse width modulation solar charge controller, then we have a tab on the maximum amount of the voltage that we can send it to the solar charge controller. But second is what? Though we are selecting the NPPT solar charge controller, this is also having the maximum tab on the voltage that we can send it to the charge controller over here. So that is why whenever we are doing the connections for the solar panels, we try to make a voltage in such a way that it is closer to the rated capacity of a solar charge controller what we are selecting over here. So that is why we have connected the panels in the parallel combination. So actually there is a standard method how we just calculate the rating of the charge controller actually. Once we know the current that we are feeding to the solar charge controller, which is 17.19 ampere, that is every panel will have a 5.73 ampere current multiplied by the 3 panels, because in the parallel combination, so we are getting the current of 17.19 ampere over here. So whatever the solar charge controller will going to use, it will able to handle at least 17.19 ampere of the current. But we are just multiplying this corresponding current by the design margin, because if any cases if we are having the higher amount of the current is passing from the controller, so that time it should not fail over here actually. So that is why the design margin we are multiplying by 1.25. So we can say the current rating of the charge controller is 1.25 into 17.19 over here. So we are getting the answer of 21.48 amps over here. So whenever we try to select the solar charge controller from the market, so we are just selecting the solar charge controller who can able to handle the current near about what we have calculated by multiplication of the design margin. So as per the market standard has been concerned, so we can select the 12 volt rated solar charge controller which can able to handle the current up to 20 ampere current over here actually. So that is why in this case we can select the 12 volt and 20 ampere rating of the solar charge controller in the designing process of the solar home systems over here.